number one, it says a coin is tossed 50 times and it lands on heads 28 times. Find the experimental probability and the theoretical probability of the coin landing on heads. Then compare the experimental and the theoretical probabilities. So let's start with the theoretical, just because you're a little bit more used to that. Just make sure that you actually write TH so I know that is the one you're talking about. So theoretical, and then leave a space, probability, and what do we want to have happen? What do we want to have happen? Yep. Heads. Yeah, so we'll just write heads. Okay. And with what we know, how many outcomes are there on a coin? 2. There's a heads and a tails, so there's 2. And how many heads are there on a coin? 1. So we have 1 in 2 chance of flipping a head. Now, that was the theoretical. That's what we have been doing. Today we're going to talk about the experimental. So we're going to at least put in EX, and then the probability heads here. Now, the denominator for this is how many trials there were. How many times did they actually flip the coin, this person? Yes, 50 times. And when that person actually flipped it 50 times, how many were heads? Yes. 28. 28. Good. So we always should reduce. So what could you reduce the 28 and the 50 by? You know, go into both of them. Yeah, 2. Sure. And you would end up with what? 14 25ths? Good. So we have 2 points here. We have our theoretical probability equals 1/2. Our experimental probability equals 14 25ths. They want you to compare them. And what gets tricky for students is the fact that we have this fraction and this fraction. We often know that this is 50%. Does anyone know what this percent is? Maybe actually going back to this fraction here would actually help you. This percents have to be over 100. Do you know what it would be? Okay, or 56%? Do you think that these are fairly close? Yeah, I would agree. They are fairly close. So you could say that the experimental and the theoretical probability are close. All right? So that would be kind of your last point. Your last point is having that sentence there. Okay, saying that they're close. What if they're not close? What if they're pretty far apart? What if we come up with an idea of why they're probably pretty far apart? Because you have to do more trials. Yep, you probably need to do more trials for the experimental, and then they'll become closer. Last one here. This is on making a future prediction. So it says yesterday, 50 bakery customers bought muffins, and 11 of those customers bought banana muffins. If 100 customers buy muffins tomorrow, how many would you expect to buy a banana muffin? A lot of you can guess this. However, I want you to see what I'm going to set it up as. So there's 11 banana, and we have 50 customers. So 11 of them bought banana. There were 50 customers. This needs to be the banana, and then this needs to be the customers. The next day, there are now 100 customers. Can we predict how many will be banana if it stays the same? So we would do what? 50x equals 1,100. Divide by 50. Divide by 50. And how many would we end up having? What'd you get? 22. And then what? What would we say? Because we got to be specific. What does this 22 stand for? Customers. And if you wanted to even be more, that would be fine. Customers would be fine. Customers who bought what? What did I do? Oh, yeah. What I was going to say is that 22 customers bought banana muffins. I would be more specific and say that's either how many banana muffins or that's how many customers bought banana muffins.